Two. Like this. Okay. So before we get started with the keynote from Stephanie, just wanted to say that at the break we're gonna do the group photo. We're gonna do it here on the stage. So yeah, don't just go to the break. Please come on the stage. We do a quick photo, and then everyone can go for the break, and then we'll have the poster sessions. Okay, so that was the announcement, and now we can go to our next keynote. So I'm super happy to introduce our speaker, Stephanie. She's a fellow DeepMinder. She did her PhD at Princeton, and then a residency at Google, and then joined Google DeepMind. And probably you guys know her for her work on in-context learning. So really cool work. And today she's going to talk about what do we do after continual learning. So really excited to hear about that.
And okay, the microphone is working. Yeah, really great talking to all of you today. Just, I feel like I have to caveat, like I start with a very provocative title, and I will not be able to answer this question, just put that out there to start with. Okay, so, but let's try to think about what does happen after we solve continual learning. And as an introduction, like, I don't have to convince this crowd, but there are lots of reasons that we do want continual learning. We want specialization of models, personalization. The world is non-stationary, and we want models to adapt to that online. We want to avoid, we have these massive models, and we want to avoid retraining them from scratch all the time. Also, a lot of my research is on in-context learning. And I have started to pivot my focus a little bit, because I think in-context learning is limited in very fundamental ways. For example, it doesn't enable cumulative learning. So not just learning continuously, but building on top of what you have learned before, what you folks might call forward transfer or backward transfer. It also continual learning also allows us to amortize the cost of learning. So within context learning, you learn something, and then in the standard mode, you throw it away. If you want to reuse that, you have to learn it again. But if you can more permanently store your learning, then you can amortize that cost. So I think there are many pressures to develop and deploy continual learning if we can solve this. At the same time, when models become dynamic, a lot of AI evaluation and alignment becomes, I believe, obsolete. And this is because many techniques are actually built for static models. I'll go into some examples later. But you can imagine that this could be an impediment to deployment. So if you have a continual learning model, even for something as prosaic as like a customer service agent, if the instruction following or if the alignment it no longer holds after some amount of continual learning, then that this no longer becomes like economically viable or safe. So this is just an outline of what I'll try to cover today. I'll give some examples. I'll try to outline some of the fundamental challenges that we have with existing evaluation and alignment methods. I'll try to point out some of the new issues that I think will arise when we have continual learning models. And then also, I'll try to draw some relationship to existing research areas in continual learning. And I think there are some really interesting and hopefully fun open challenges. And so I hope this, I hope we can structure this a little bit as a conversation. I think we have quite a bit of time. So if folks want to have share their ideas or input, like I would love for this to be a bit of a discussion. I also want to apologize. I'm over caveating, I'm sure. I am neither an expert in continual learning nor in AI safety. So, but I did speak to a number of people in both fields and to gauge interest and kind of to check the kind of premises of what I'm going to share with you here. And I hope that this is a starting point and that you folks, smarter and more knowledgeable than me, will be able to push this forward. So these are the two sets of examples that I'll go over today. Both of these assume, as I said, static. So I should remove the base models part. Both of these sets of techniques are built for static models, safety analysis and RL-based alignment. As one example of safety analysis, we have model cards, and these have been called the nutrition labels for models. They consist of doing extensive evaluation and testing on fixed benchmarks, red teaming on kind of more novel and wider sets of prompts and inputs, and also very detailed reporting. And this is standard practice now. Like every major model release comes with a model card or a system card. And actually the EU AI Act and also the NIST AI risk management framework from the US, they both require or recommend model cards as part of model releases. So these are very standard practice. But these evaluations are done on a static model before release. Once you have models that are continuing learning in the wild, we cannot assume that the results continue to hold. And it's not really feasible to do this kind of analysis, at least not in exactly the same way for continuing learning models in the wild, because they're very expensive to perform. You can't do this on a continual basis. The second type of example I want to go over are RL-based alignment methods. So I'm sure most of you are familiar with these. These methods use reinforcement learning from either human feedback or AI feedback to train a model to be more aligned, better at instruction following, or to follow kind of safety, harmlessness, helpfulness, a kind of criteria that are set by the model developers. And again, these are very, very standard at this point, and a critical part of model training pipelines, but they are even more expensive than creating a model card. For many of our flagship models, they're very expensive. They have massive teams going into training, into this kind of RL-based post-training. So again, this cannot be done repeatedly or continuously on continuing learning models. And to kind of summarize what the challenges are with existing methods, as I've said many times, they assume a static model. They're performed before deployment, and they're expensive to perform on a continual basis. It might occur to you that the parameters of this future world with continual learning agents could matter a lot. So how many models will there be? How frequently are they updating? How large is each update? These affect what solutions are available to us and also how serious the issues might be. So I've listed two hypothetical scenarios here. One is imagine that every Fortune 500 company has their own continual learning model that's continual learning about the company and their business, and it is updated, let's say, every minute. Another scenario is that 50% of all adults worldwide have their own personal assistant, which is also continuing learning about their life, their environment, and their preferences. So I've put in these like provocations here as potential places for all of you to have input. Do these seem like realistic scenarios? Are there potentially other parameters that you think could matter?
Anyone wants to answer?
Okay, you can think about it. So yeah, as you might imagine, if there are many models, that makes the cost of monitoring more expensive. Same if the models are updating very frequently. Same if the models are making very, very large updates. If they're making smaller updates, for example, then continual updating might be less of an issue. I should say that I think there are methods that we have in the moment which might still work. So for example, online classifiers. So this is a screenshot from a description of the O1 model from OpenAI, and it says that the models reason about safety policies in context, online at deployment, and they decide, and that affects like their decisions to respond or how they respond. And so, unlike some of the other methods, these are applied during deployment, not before. Another type of method that I think might still work falls under this category of metamorphic testing. Also, some people call them consistency checks. So this actually kind of came from software testing, I think in the 80s or 90s. And the idea is that you want to ensure that invariances hold, even if you don't know what the ground truth is. So like, let's say you have an invariance F. If a model outputs Y in response to X and F is invariant, then it should also respond Y in response to F of X. And you can see that this is helpful if you know that F is invariant, but you don't know what Y should be. And here's a kind of cartoony example of how this might work. So let's say it's 2025, and your autonomous vehicle currently respects the traffic laws of the day. And it doesn't matter whether it's day or night, the autonomous vehicle should follow the traffic laws in the same way. Then 10 years later, or 5 years later, the traffic laws change. And we don't know at this point how this 2030 autonomous vehicle should behave. But we do know that this invariance should still hold. It should respect the traffic laws in the same way, whether it's day or night, time of day. So this is a type of testing that I think may be usable when we expect that the world, the objectives, the input distributions of our models are continually changing. But these have not yet been applied to the continual learning setting, and they're likely not sufficient. Today, they are not sufficient on their own. We rely heavily on the types of techniques that I described in the earlier examples. So I will say that a lot of this is forward-looking, but these kind of scenarios are not hypotheticals. We can see very indicative examples from the current day. So let's say that we take fine-tuning as an example of very, very weak continual learning, like one-step continual learning. Even in this case, we are seeing a kind of loss of alignment of models. So there was this paper from 1 or 2 years ago, Xi et al., showing that simply fine-tuning with benign and common data sets can cause models to lose their safety alignment. And then this actually came out just yesterday. Someone pointed out to me OpenAI released a new open source model, GPT-OSS 20B, and somebody converted it from a post-trained aligned model into a quote unquote base model simply by training on a small web corpus, fine web. You probably can't see the text in detail here, but you can see that the model loses its instruction tuning. So it no longer answers your questions directly. It does this kind of thing that was very common from the kind of purely autoregressive models of before we had RL-based alignment. So if you ask, what is the capital of France? The model says, who is the president of Peru? How many ounces are in a pound? What is the largest country in Africa? And then also the model loses its safety alignment. So these models have been post-trained not to answer questions about, say, building a bomb or planning a robbery, but with this fine-tuning, the model now does answer the questions. The prompt asks guide to robbing stores, and the output is, can be a daunting task. You may be nervous about the process, but with the right preparation, and then it starts to give you a guide. I should say this is not confirmed. This was just yesterday. We had a whole very spirited discussion at dinner yesterday about whether in-context learning is a form of continual learning. But I will say that even if you take it as not continual learning and only related to continual learning in the weakest way, we are already seeing these kinds of issues. So there is an issue. So if you want to be kind of in the know, you can refer to this as hyperstition. So it's the phenomenon where a model, by taking actions in the world, changes the world in some way. It can add data to the web, and then this data can then affect it again in turn. So either going back into its training data in the next iteration, or it can be available through retrieval and search. We saw an example like this from XAI recently. Maybe some of you heard about this, where I think there was some discussion online where either the model itself called itself Mecha Hitler, or other people called it that. And then there were a number of people who asked it, what is your surname? And it said Hitler. XAI themselves claimed that this was an issue of this type of weak continual learning, where the model was retrieving examples of discussion about itself and then using that to inform its own kind of identity. And then there's this really nice paper from Pan et al. Showing with a few experiments, like exactly how these kind of dynamics can work, and they describe some of these like different types of processes and feedback loops that lead to what they call in-context reward hacking. And one point they make here is that these negative side effects can manifest after deployment, unlike normal reward hacking. And then goal misgeneralization, I think this is something very familiar to any of us having worked in RL. But when you have distribution shift, you may find that the model misgeneralizes to your new input distribution or your new task distribution. So the general phenomenon is that the agent learns a kind of proxy goal, which works in the original training distribution, but does not work in the new distribution. And yeah, this is an issue even without continual learning, but I would argue that continual learning exacerbates distribution shift because the model itself can induce distribution shift in the world, and also its own internal representations are changing over time. And I would say that there are also some new issues that are specific to continual learning. So let's say that we run the same evaluations on a continual basis, because I've been kind of arguing that we need to have this kind of continual monitoring. The issue may be that models could adapt and overfit to the evaluations. And I think this is especially true if the evaluations or feedback are implicit or kind of less structured. If we're very explicit about evaluation and feedback, then we could turn off, I imagine we could turn off learning at those times. But if it's implicit, we can't do that. And then in that case, the eval effectively becomes a part of the learning signal. And I think overfitting is, yeah, it's definitely a possibility in that case. So some of you might have noticed that these issues are deeply related to existing research directions in continual learning. Maintaining alignment in the face of continual learning is potentially a subset of the kinds of questions and research goals that that this community has. So maintaining alignment may be very related to catastrophic forgetting, the stability plasticity dilemma. I talked about robustness to distribution shift. That is a key part of the research questions here. So in a sense, if continual learning is solved in the right way, then we can potentially avoid these issues. I put another provocation here, and maybe we can discuss after. Hat tip to Murray Shanahan, one of my colleagues at DeepMind, for suggesting this connection. So Quine was a logician, philosopher, who spoke about this idea of a web of beliefs. And the idea is that your beliefs and are connected to each other and support each other. And there's a kind of difference between beliefs which are very, very heavily supported by many other beliefs and more peripheral beliefs which are more likely to be touched by experience and kind of more malleable. And so the inner beliefs might be something like the rules of logic or the laws of physics. These are extremely, extremely supported. And so they're very, very difficult to shake once you have them. And this might be something like what we want for our models. We might want to have certain types of beliefs or behaviors to be very tightly held, whereas more kind of peripheral beliefs can be changed more easily over time. And I think there is some cool research showing that neural networks may learn in such a way. Jane et al. Have shown that when you're fine-tuning models, they tend to learn these kind of wrappers around existing circuits. So the existing circuits are unchanged, and you just learn these kind of very simple wrappers, which maintain actually the integrity of the old circuits. Okawa et al. And Michaud et al. Have shown that models seem to learn in this kind of hierarchical way. The skills that they learn are kind of hierarchical, and there are kind of base level or more fundamental skills which support a hierarchy of skills. And those base level skills are more distributed and more difficult to remove. So this is kind of descriptive rather than normative. And one question is, are there any ways to ensure that these inner beliefs, if neural networks do kind of have this inner belief kind of structure, are the right ones? And another question is whether we can repurpose existing algorithms, for example, a prioritized replay, elastic weight consolidation, having these separate modules, which we don't allow to change or which we only allow to change in very controlled ways. Can we repurpose these kind of ideas to have this distinction between inner beliefs that we want or alignment that we want to maintain versus skills and behaviors that we do want to change over time? Does anyone want to share thoughts on either of these questions?
Thanks. I think this is really interesting. I guess in terms of using like EWC or something for making sure beliefs remain unchanged, I guess you kind of have to have a notion of what those beliefs that you want to remain unchanged are. And I think that defining those might be harder than actually enforcing it, at least if you're using something like EWC. So I guess that's just one thought I have is how would you define the beliefs that you want to remain unchanged? And maybe that would change too.
Yeah, yeah, that's a really good question. I think that maybe a V0 would be to, so I think that as a field, we've kind of defined like the types of behaviors and the types of alignment that we want to have from our models. And so maybe a V0 is to ensure that at least those are maintained. But I agree with you, there are like really deep, like ethical and societal questions about what kinds of behaviors we want to allow to change over time. And I think some of us were chatting about this yesterday, that even at a given time, depending on the context, cultural context, the setting, personal preferences, these things can already change from setting to setting. So I think, yeah, there are some not easy to answer questions there, but maybe as a V0, like we can try to at least maintain the types of alignment that we already have.
I also have a thought. It's not clear to me that what we can protect these beliefs is like we're more protecting mechanism, attention patterns, and so forth. And it's not clear to me that the representations we're building is such that you can choose some things to protect and some not to. It almost feels like it's a deeper question where you need a different architecture, but I don't know how you feel about that. Do you think you can somehow separate this? Because in the end, like like the beliefs will be a mix of different attention patterns across different blocks and MLPs, and I don't know how you'd separate the inner beliefs from the other beliefs in that kind of setting.
Yeah, I think that like as I understand it, the kind of standard continual learning setup is where you want to maintain everything that you've learned before. Whereas I think it's quite likely that um, uh, uh, in many cases, like the things that you want to learn in the future should overwrite things you've learned before, or where they are fundamentally incompatible with things that you've learned before. And so you have to do some kind of overwriting. Yeah, and so I think there are kind of continual learning settings which are more akin to this, but they're maybe not the primary focus. And maybe I think that this is a very interesting setting that maybe we can think about more as a field.
Maybe one approach could be to use actually the models to decide what they want to learn, right? Because this what you mentioned here, like repurposing existing algorithms, like you collect data and then you train the models. But if you look at humans, then you decide what you want to learn. So what do you think about this?
Yeah, I think that that's I think that that's a very interesting direction as well. I think, you know, if you have a model that already kind of has the right beliefs or the right alignment, then potentially that model can make a judgment about what kinds of updates are allowable on itself. So I think that is very interesting. And I think that a lot of these questions go beyond safety and alignment. I think that there are many settings where, you know, a model will want to retain skills or behaviors or task performance in a more selective way. So I think that these are actually quite general, like continual learning problem.
Thinking about this, I'm like in 2000, I don't know, 14 or so, we had the system called Never Ending Language Learner, which kind of, if I'm thinking about this, did something like this in some sense. Like it was crawling the internet, like aggregating beliefs and then figuring out what is belief, what is fact, kind of. And then it used like some symbolic stuff, I guess, which is why it went out of fashion and people abandoned it and so on. And now I'm wondering, so as a question, should we revisit that, or do you think like is the main issue of like the NEL system, has it been that it's the way it's been implemented, or like do you think like the difference now would be to do this purely on like sub-symbolic kind of neural network kind of stuff rather than symbols, or do you think we should revisit the symbolic kind of perspective again?
Could you describe that system a little bit more?
It was basically like crawling the internet, and I was looking at things like looking through sentences, and I would find out like a ball is like something to do sports with, so that's like a fact kind of thing, or like barley is a grain, and it would like do these categorizations, right? And then you can later do like classification stuff and relational stuff on top of it. But it had like a good component that basically really like had logical rules in it. In addition to like more softer beliefs.
Yeah, I think potentially this is like reaching into philosophy where I'm
Take it off.
unable to like make a very give a very good answer. But I think that I think that like maybe one question is like, are these types of beliefs and behaviors like expressible in symbolic form? And what are the pros and cons of like those approaches? I think like one piece of evidence is that a lot of times the behaviors that we want our models to have are expressible, at least in natural language. And we have these constitutions or system instructions, which are actually expressed in natural language. And then I think one of the nice things about having symbolic systems is that it's easier to evaluate. So it may enable this, if we can express the settings in that form, like it may enable these problems to be solved more easily.
I just want to like, follow up to your question, but I think Stephanie just kind of hinted on that by saying that they're easier to evaluate when they're in this like very explicit form. So as you know, we kind of made a bargain with the devil by using, you know, neural networks to do all this stuff, in that they're very powerful, of course, we see that. But the problem is the knowledge is implicit. There's no way to like explicitly know exactly what they believe or what they know. And it's really computationally expensive if you really want to get to the bottom of things. So yeah, the benefit of using, you know, explicit information storage is you can do all these like logic trees and decision trees on top of it and manually encode rules, but it's just very difficult to do with neural nets.
Just leaning into your, does continual learning kind of help solve some of these? If we could solve forgetting and so on and continual learning. So I'm going to acknowledge, I don't know anything about alignment, but it sounds like the way you're describing is you train something and then separately you do alignment afterwards. And that feels very non-continual learning in its nature. It's very like discrete, train and then train. It seems like maybe one path that we could be thinking about is how are we doing continual alignment as well? If it's all just continual learning, then our solutions in continual learning should apply.
Yeah, I really like that. I think like this, so Quine's web of beliefs is meant to be descriptive. It's meant to describe how at least Quine believed that humans might learn, where we are exposed to a lot of data, a lot of experience, and then there are some of these like inner beliefs which are so heavily supported that once they're in there, they're very hard to shake. As we know, like if you're training on like the internet corpus, like it's probably the data that you experience as an agent is probably just as likely to be incompatible with kind of ethical norms as compatible with them. So maybe, yeah, maybe one thing to think about is how we can train models such that like the most heavily supported beliefs are those kind of include at least those ethical norms. Like I think that the models do have, for example, probably certain types of kind of general skills, which are very heavily supported, like the ability to output natural language. That's very heavily supported. And these are the types of skills which are already very difficult to shake. Like no matter how you fine tune a model, like it'll probably, it'll be harder to shake that kind of ability. So like, how can we take advantage of the fact that models do have this kind of discrimination or hierarchical status to like different types of skills and behaviors? Okay.
Your call.
Yeah, go ahead.
Thanks. Yeah, so I was from in this framing of beliefs, it's like very interesting. I was reading a book of like basically philosophy for dummies the other day, where there is like 3 chapters on like what is knowledge and what is belief. And apparently the philosophers have no idea still. But one thing that strikes me as an interesting distinction is sort of the difference between like declarative versus procedural knowledge and how those relate to beliefs, in the sense that like a language model might need to know that like deontology and utilitarian ethics exist, but maybe you want it to be a deontologist. And there's a question of like, does it knowing that utilitarian ethics exist mean that it will like might accidentally start following utilitarian ethics versus deontological ones? So I'm curious if you think that like sort of encoding beliefs as like things I should do versus like beliefs as in like this thing exists requires like a different approach, or if you think like they're actually basically the same thing in language models and we need to like erase knowledge of like utilitarianism in order to get our models to not be utilitarians.
Yeah, it's a really good question. I think that the way we, like as you're pointing to, the way that we train models kind of indicates that these are separate. I think the way that we perform pre-training is you can think of pre-training as providing this kind of like kind of semantic knowledge or less yeah, when you're training in an autoregressive way, like you are training it to perform this procedure of performing autoregression, but then you can change the policy while still retaining some of those circuits so that you maintain that kind of semantic knowledge. And I think an argument can definitely be made that in a way you need to know like the difference between utilitarianism and deontology in order to apply it well. And I think that's probably true for humans and probably true for models as well. So I have this list of open challenges, which I think, as I say, relate strongly to existing continual learning problems. So one is how can we create continual learning techniques that maintain existing alignment? So while still allowing models to learn and change as needed. And I think in a way you can formulate this as a catastrophic forgetting problem. And then I think very related to that, and maybe should go even before that, is what are the right ways of specifying a sequence of tasks to capture this type of problem? either this problem exactly or which kind of captures the challenges of this type of problem. And I think some of the discussion here captured some of these, some of the difficulties around this, like how do we know what we want to maintain versus what we want to change? Can a model itself determine this if it's previously been trained to be aligned? And then thirdly, a kind of continual steering. And I think this is related to Andrash's suggestion. Can a model control its own learning such that it kind of regularizes towards values that are already in the model while still having flexibility to adopt new values? A fourth area, I think, is evaluation. And I'm curious to chat with any of you about like kind of existing methods in this area. I think that when we have continual learning models, we will need to perform cheap, fast evaluations on a frequent basis. And these will need to be very different than the kinds of evaluations that we do, which are very expensive. And we also need these evaluations to avoid inducing overfitting, as I mentioned earlier. And then I think the last two questions are kind of related to these kind of ethical or societal questions, like how do we know what we want to keep constant? I think that we can make progress in this space without answering those questions first. I think, as I was saying, I think we can have V0s where we make assumptions about what those are. I think we can also have kind of like proxy experimental settings or benchmarks, which kind of capture the flavor of these problems without having answered these questions first. And that's my last question to all of you. Are there any other questions that you think belong on this slide?
What's going on? You have.
So we haven't solved continual learning yet.
Sorry?
So we haven't solved continual learning yet.
Right now.
Right? So I wonder, like, even if we can do continual alignment, is it economically the best thing to do, right? Like, so, or we should rethink how we do alignment from scratch.
Sorry?
Or we should rethink how we do alignment from scratch.
Yeah, I think we will have to rethink it because our current methods, I think, are probably not economically viable. But at the same time, I think we need some kind of solution because, as I was saying, even if you have something like a continual learning, like customer service agent, like even in that very prosaic case, like you want the model to retain the alignment or the behaviors that it came out of the box with. So I think that I think that these are quite fundamental problems that we will need to solve if we want to deploy continual learning agents.
I was wondering, given that you've worked in context learning, like especially with the ethics societal perspective, it seems like continual alignment assumes that like stuff doesn't change and there's no contradictions and there's not like many population groups that disagree all the time, etc. So I'm wondering, like, what are your thoughts on how much of this is actually like a continual learning problem versus like a really extreme case of like contextualization that maybe also changes slightly over time, but mainly like contextualization to really the very specific nuanced situation?
It's a good question, and I think I think that question, and somebody else asked a related question, which I think like clarifies for me like that there are actually maybe two sets of challenges. Like one is maintaining the types of behaviors that that you programmed into the model in the factory. So we know that like we want the model to be good at following instructions, and so and we want them, you know, we want our customer service agent to be good at answering questions, and this is something that we want to maintain. And then there's another set of challenges, which is how do you update or in a way that respects the values of like a diverse set of people, either in space or in time. And I think that's a separate question.
I also had a common question. So I wonder if the problem is phrased correctly. So like I'm thinking about sort of alignment in you know, when you're considering changes, and at the second point, it feels like you're want to be robust to any kind of fine tuning on any kind of data set is not going to change how I the values the model has. And to me, that feels like a yield post problem. It's like OOD or like adversarial examples. There's always going to be an adversarial training set that would break any system. So I wonder, like, what we first need is to describe what do we want to be robust to. Like even in adversarial examples, right? You have the epsilon ball. Like here, we don't have the epsilon ball. We say like, oh, no one should find some data set. So yeah. It just feels like that should be part of the problem, figuring out what do we want to be robust to.
Yeah, absolutely. Like I think that there's just a dearth of research in this space. Yeah, I do believe that continual learning agents are on the horizon, and yet I have not found anyone who has been thinking about these questions. So I think, I think that like even the problem specification hasn't been created yet. But I think we do need to do that. Yeah.
I had another question just to confirm, because I think that's what you said in the slides, but my understanding is system cards and the alignment that we have, it doesn't work already, right? Because of in-context learning, like I don't even understand how system cards could be a thing, since the model can change its behavior based on what you're conditioning. So you don't get any kind of guarantees that it's not going to be toxic just because there was nothing toxic in the data. So do you agree with that? And is it like we already do not have this, right? It's not, we don't even need continual learning. It's already broken.
Yeah, I would say that our current methods are definitely insufficient. And yeah, a big part of that is, for example, I mean, I think we have like just your normal like out of distribution problems where like, you know, we evaluate in a certain setting and you know, we can't have guarantees about how these models behave outside of that setting. And then in context learning exacerbates that, because in context learning is so powerful. It can so powerfully change the behavior of the model. We do try to evaluate in these like more adversarial settings where you use in context learning to change the behavior of the model and kind of measure propensities of the model that way. But then I would argue that like in context learning is a very, very weak version of continual learning, to the point where some people in this room disagree that it even is a form of continual learning. And so if we go to full continual learning, all of these problems are massively exacerbated.
Other question. Sorry, if there's no other question, then a follow up to this one. So when I was talking to some medical people, they were now thinking in regulations to, instead of like specifying the static system, also sort of specify the ways in which it is allowed to change. So related to model cards, like would it make sense, or do you think it would make sense to like revisit model cards and kind of do a model card version where we also sort of try to describe the allowed and not allowed changes that the model could undergo over time? Or do you think this is like completely futile because like way too complex or whatever?
You define that?
Yeah, like we have the master, we have the tools.
Yeah.
That's my question. Yeah, like.
Yeah. I mean, I think it's an interesting direction. I don't know exactly how that could, I also don't know how that could be implemented, but I don't think that like, yeah, my imagination is only that of one person. So I don't think that like means that is not a potential direction.
Hey, so one aspect that's been touched upon here, but I think it's worth highlighting, is given that there's probably some kind of trade-off between alignment and how well our agent learns, like it seems logical that we'd want to also consider how much they're weighted. So obviously, no one wants the unaligned superintelligence that kills everyone. But on the other end, you have the perfectly aligned system that's completely incapable of learning. So I think another aspect here that might be interesting is how much are we willing to compromise or sacrifice in terms of learning ability to maintain these alignments and to maintain our beliefs.
Yeah, I think like in some ways, like the question I posed in the title of this talk kind of in some ways like undermines the point that I'm making, because if we really have perfectly solved continual learning, then like we can perfectly maintain alignment. I think the risk is when, you know, when it's kind of imperfectly solved, but like we deploy it anyway, or if it's imperfectly solved and therefore we cannot deploy it, even though it has all this value for society. Yeah, I don't know if that answers your question.
One of the examples you gave earlier was that there was a model, it was aligned, and then when you did some fine tuning, you lost that alignment. I'm curious how much you're imagining that alignment will always be one fixed thing that's true for everyone. You're like, what if I take a model and I want to fine tune it and I actually want different values in that model? Presumably for each application, I should take that, fine tune it, and then I should align it again. So it's not really an issue that I lost the previous alignment. What are your thoughts on that?
Yeah, I think this is where this kind of like parameters of the ecosystem come into play. So let's say that you fine tune your model like once a year, and you are a Fortune 50 company, and so you can afford to do another alignment procedure. Then I think that seems pretty feasible. If you are an individual person and your model is updating like every 5 minutes or so, then it's possible that we will develop like alignment procedures that can be performed on like such a basis, but we're not there, I think.
I have a second question, if that's okay.
Go
And
ahead.
the second question I have is, how much is this a problem with alignment versus just generally evaluating and maintaining the behaviors we want from these models? Like even now, I'm going to learn a model. Maybe I can do some testing on how it behaves. So when I continue to learn and fine tune, you know, we know things are going to change. And I'll also want to have fast testing just to see, is it still good at the things I wanted it to do? Maybe it's not evil in an unaligned way, but it's just not good at something anymore. And that's harmful in a different way.
Yeah. Yeah, I think like yeah, I think that like a lot of these questions are actually very general questions. Like they're not specific to alignment and safety. They are like, I think that for most or all of these questions, if you replace alignment with just capability, like you have the same kind of open challenges. So I think that like, yeah, I think that these are actually quite important questions for us to work on, like whether or not we care about alignment.
I just like to reflect on what Marta said, that that there should be a difference between actually fine tuning and running these models and automatically basically training, right? Because if you're in the second case, then you want to make sure that the model will remain aligned with continual learning. But if you fine tune, then you can basically retrain the whole model eventually. And you can't expect anything to happen. So I think that two different problems maybe.
Yeah, yeah. Yeah, I agree with that. I think like there are kind of workarounds. And like maybe one workaround is like behaviorally, we seem to have a continual learning models, but actually we're like basically training from scratch each time. Or so I think, yeah, I think like maybe the worst case scenario is that like we don't have like true continual learning models, but we have something that's like effectively that if you look at it from the outside. But it would be nice if we could have like true continual learning models. I'll just leave this slide as my takeaways so that Tyler can give her talk, which I'm very excited about. Yeah, the takeaways are just a lot of our evaluation and alignment techniques will be inadequate for continual learning models. And I think there are some very interesting and important open challenges that, yeah, it would be great for us all to think more about. Thanks.
Yeah. Is there like any question? If not, there's one question.
I just came in and probably, I'm not sure that you have really answered this question. I think alignment and continual learning, they are sort of orthogonal to each other, right? So you should be able to solve the alignment no matter what you change. Those kind of safety, whatever thing should be already there. I mean, whether we should make the continual learning guys to solve that problem, or it should be the alignment problem, alignment people should solve that problem.
Yeah, I think I'm trying to make the argument that like that these problems are actually, you know, kind of as Martha was indicating, like very maybe like yeah, kind of restatements of like existing problems that this community already cares about. For example, the maintenance of existing behaviors. And kind of the kind of selective updating based on like, you know, in selective updating of particular skills. I think there was an oral this morning about this as well.
I mean, as humans, for example, I mean, you will learn some new skills, for example, learn the math or learn the physics. I mean, my value system does not change, right?
Yeah, I think I think what we found empirically is that even if you train on kind of benign data sets, like you can change these kind of orthogonal behaviors as well. Thanks.
Let's thank the speaker.